Pearson product moment correlation. Our objectives for this lesson is to identify different types of correlation, find and interpret the correlation coefficient of the given problem. So by the way, Carl Pearson, he was an influential English mathematician and biostatistician. In 1911, he founded the world's first university statistics department at the University College of London and contributed significantly to the field of biometrics, meteorology, social Darwinism, and eugenics. We have three types of correlation: positive correlation, negative correlation, and zero correlation. For the positive correlation, the graph indicates a direct correlation between variables x and y, which appears to be increasing. For the negative correlation, the trend of the data is decreasing. The variables are negatively correlated. For the zero correlation, the scatter graph of the data above is neither increasing nor decreasing. This graph represents a zero correlation. We also have types of linear correlation. The perfect positive correlation. The trending is upwards and it is equal to 1. For the highly positive correlation, we have 0.8. The low positive correlation, 0.3, and the scatter graph of the no correlation shows that it has zero correlation. We also have low negative correlation, which is equal to negative 0.3. Highly negative correlation shows negative 0.8, and the perfect negative correlation is negative 1. The Pearson product moment correlation is the most widely used in statistics to measure the degree of the relationship between the linear related variables. The Pearson correlation would require both variables to be normally distributed. We have here the formula for our Pearson correlation coefficient. We have R equal to N multiplied by the summation of x and y minus the summation of x times the summation of y, all over the quantity of n, the summation of x squared less the summation of x squared multiplied to the quantity of n times the summation of y squared less the summation of y squared. We have here the chart that summarizes the correlation coefficient and strength of relationships. If the correlation is 0.0, there is no correlation, there is no relationship. If it shows positive or negative 0.01 to positive or negative 0.20, it has very low correlation, almost negligible relationship. If it is positive or negative 0.21 to positive or negative 0.40, it is slight correlated. It has definite but small relationship. If it is positive or negative 0.41 to positive or negative 0.70, it has moderate correlation, a substantial relationship. If it is positive or negative 0.71 to positive or negative 0.90, it is highly correlated. It has a marked relationship. If it is a positive or negative 0.91 to positive or negative 0.99, it is very high correlated, which has very dependable relationship. If it shows positive or negative 1, it is perfectly correlated. It has perfect relationship. Here is an example. A data of mathematics score or X and the scores of an English test or Y. To get the first column or the X squared, third column rather, you multiply the value of X by itself, or for the first column we have 4 squared, which is 16. So we have here 5 squared, 25, 9 squared, 81, 2 squared, 4, and so on. And the summation of x squared is 296. For the fourth column, or y squared, we square the value of y, or the English scores. In this case, we have 5 squared, which is 25, 4 squared, which is 16, and so on. And the summation of y squared is equal to 310. For the last column, the product of x and y, we multiply the mathematics score and the English score. For the first row, we have 4 times 5, we get 20. Next row is 5 times 4, we have 20, and so on. And the summation for x and y is 298. Applying the formula, we have this solution. Substituting all the amounts, we get a correlation of 0.92, which shows a very high positive correlation. It has very dependable relationship. Thank you for listening. If you have questions, just give me a message. Keep calm and have fun learning. Thank you.